Welcome back to another edition of the Deep Knowledge Cast. In this explainer, we will provide a foundational analysis of artificial intelligence, beginning with first principles.
We will proceed through 5 chapters. We will begin with a formal definition of artificial intelligence, then examine its core computational mechanisms, review its specialized domains, survey current applications, and conclude with the operational boundaries and challenges of current systems.
We begin by establishing a precise, internationally recognized definition. A clear, standards-based terminology is essential to serve as a stable foundation for technical and regulatory discussions.
This is the revised definition from the Organization for Economic Cooperation and Development. It was updated in 2024 to formally include the generation of content reflecting recent developments in the field. This provides a technical and neutral starting point for our analysis.
Let us deconstruct the key components. An AI is a machine-based system that processes input to generate some form of output. A critical aspect is that these outputs, be they predictions, recommendations, or other forms of content, can influence physical or virtual environments. The definition also notes that these systems can exhibit varying levels of autonomy and adaptiveness.
We will now examine the high-level mechanisms that enable these systems to function. Our focus will be on the field of machine learning, which underpins many contemporary AI systems.
Machine learning is a subfield of AI. It provides systems with the ability to identify patterns in data and make subsequent predictions or decisions, without requiring exhaustive, explicit programming for every possible contingency.
Machine learning is broadly categorized into 3 main approaches, or paradigms. Each is distinguished by the type of data it uses and the feedback mechanism it employs during its training process.
The 2 most common paradigms are supervised and unsupervised learning. In supervised learning, the system is provided with structured, labeled data. It learns to map specific inputs to known outputs. By contrast, unsupervised learning uses unlabeled data, and the system's objective is to identify inherent patterns or structures within that data.
The third paradigm is reinforcement learning. In this approach, a system, often referred to as an agent, interacts with an environment. It learns to perform actions to maximize a cumulative reward, receiving feedback in the form of rewards or penalties for its actions. This table summarizes the primary distinctions. Supervised learning, using labeled data, is commonly applied to classification tasks. Unsupervised learning, with its unlabeled data, is used for clustering. Reinforcement learning, which operates via trial and error, is frequently employed for control systems.
Having covered the underlying mechanisms, we now turn to the specialized domains where these techniques are applied. We will examine key areas of AI research and application.
Computer vision is a field of AI focused on enabling systems to process and interpret visual information from sources such as images and videos. Common tasks include object detection and scene analysis.
This image shows an application of a computer vision model. A text prompt is provided as input, and the systems generate corresponding images. Platforms like this are used in research to evaluate and compare the output of different vision models.
A second major domain is natural language processing, or NLP. This field is concerned with enabling computer systems to process, interpret, and generate human language in both textual and spoken forms.
These domains contribute to the field of generative AI. This area of research focuses on systems that create new content, including text, images, or computer code, by learning statistical patterns from large data sets of existing examples.
We will now review some concrete examples of how these systems are currently being deployed in professional contexts, with applications across sectors such as medicine, law, and manufacturing. This quote is from a 2024 study in medicine. It is an example of a prompt used to instruct a system to assist human experts in radiological differential diagnosis by synthesizing patient histories with imaging findings. Beyond medicine, systems are applied in the legal sector for the large-scale processing of documents. In industrial settings, computer vision and reinforcement learning are combined to facilitate autonomous assembly processes in manufacturing. Our final chapter will address the operational boundaries and technical challenges inherent to current AI systems. A clear understanding of these limitations is essential for responsible development and deployment.
The concept of the stochastic parrot, introduced in a 2021 research paper, serves as a conceptual tool for framing a key limitation.
It describes a system that can regenerate language based on statistical patterns, but without a grounded model of the meaning behind that language. Two significant technical challenges are non-stationarity and adversarial examples. Non-stationarity refers to the fact that the statistical properties of the real world change over time, potentially reducing the accuracy of a model trained on historical data. Adversarial examples are inputs with small, often imperceptible alterations that can cause a system to misclassify them.
To address such challenges, international standardization bodies are developing governance frameworks. These frameworks emphasize principles such as explainability, which concerns the ability to describe a system's internal mechanics, robustness, its ability to perform reliably under varying conditions, and transparency.
This raises a central research question. As AI systems are integrated into critical fields, what validation methods are required to ensure their outputs are both reliable and robust? The development of rigorous verification and validation techniques remains an active area of computer science research.
Thank you for listening, and we look forward to seeing you again soon. Goodbye, and continue learning.